Okay, this is Mr. Benson, and it is 3:53 on a Friday, and what better things to do than to take a practice test? So I thought I'd take it, and I'd kind of show you how to go through the problems you just saw on the practice test that you just got. And consider this, if you were to take their test right now, this is probably the score you get on that test. So this tells you what you know, what you don't know, and what you need to know before the test on this upcoming Friday. Okay, so here we got our first number problem. I'm going to go through these. I'm going to probably make a lot of mistakes, but hopefully not. Let's see what happens here. A card is drawn from a standard deck of 52 cards. Find the probability of the following events. The card is less than 8 or a red face card. Now the key thing here is or. When it says or, what you just do is you shade all the cards that are less than 8 and you shade all the cards that are red faces, and then when you shade them, you just count them up. Don't count them twice, just count them up. Shade all cards. And then count those. And we want to find the probability, and we know there's 52 cards, so whatever we get, whatever we count out, it's going to be over 52. So let's just go over to our cards. Cards less than 8 or a red face card. So I got my document up here. So the cards that are less than 8, I wonder if I can highlight it. Yeah, okay, I can highlight. So less than 8, so we got this stuff right here. No, it's a less than, right? So don't include the 8. So all these cards are less than 8ers, and then we need all red face cards. Now this would be a mutually exclusive event because there's no overlap here, which makes it a little bit easier. When we put all of it together, if we count this up, we have 6 cards here altogether, right? Excuse me. And then we have 1, 2, 3, 4, 5, 6, 7. 7 times 4, which is 28. So we have 28 plus 6, which would be 32 out of 52. But we got to simplify that down, of course. So we have 16 over 26. And one more time, let's make that 8 over 13. So we have 8 over 13. That's our answer for this one. Let's bring it back to the test. And we'll put in 8 over 13. Hopefully I started off on the right foot. Just say my answer is a fraction. Yeah, so there we go. Check that out. How do I do? Oh my gosh. That's a great way to start. What did I do wrong? Cards less than 8, ace is low, or a red face card. You're right, your answer is a fraction in simplified form. Did I count that wrong? Less than 8. 1, 7, 14. 2 14s gives me 28. And then red face cards, 26. 28 plus 6. Oh, 34. Oh, guys. Okay, that's why you got to slow down when you do these things. So if this is 34, that's 17. 17 out of 26. Can't be simplified down, so we'll make that a 17 out of 26. Just this right there, 17 out of 26. Whoa. See, it can happen to all of us. So we'll change that to a 17 out of 26. 17 out of 26. Check that out. Boom. There we go. So, lesson, slow down. Take your time. But I don't have a lot of time, so I'm going to go kind of fast. I'll probably make more mistakes. Okay, find the number of permutations of the letters. Well, it would be really easy if there weren't duplicates, but notice in this word there are 2 E's, and look at there's 2 T's right there. So what you need to do, are there any other duplicates? Just scan in. I don't think so. You need to count up how many letters there are all together. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 factorial letters, or ways to arrange these letters, if they were all different, but they're not. And what we have to do is account for the duplicates and how many ways you can arrange those duplicates. Well, since there's 2 E's, you can arrange those 2 factorial ways, so we got to divide that out, that replication. And there's 2 T's, so you have to divide that out too. So if I were to take this, put it in the calculator, I do 8 math, we'll go over the factorial, divided by, this is where you got to use parentheses. If you don't do this, you're going to be, it's not going to work, guys. It's not going to work. Okay, there we go, 4. And then times 2 math over 4, and then close that parentheses off, and we get 10,080. Okay, hopefully this one goes a little bit better than my first one. 10,080. Check that. There we go. Okay, I'm on a roll now. Okay, question number 3 says the CD has 7 songs on it. If a CD player randomly selects an order in which the songs are played, you can do, you can randomize and it plays all the songs. And how many different orders can the 7 songs be played? Well, this is a fairly just a simple problem. It's just kind of like each song's a letter and a word, and all the words or letters are different. So this just turns out to be 7 factorial. Now some people think about a CD, and when they think about a CD, they think circular. And just because it's circular doesn't mean it's 1 minus that 7 factorial. It's just 7 factorial. So we'll just put that in our calculator. 7 math 4, and we got 50/40. There we go. Let's check that out. See how that went. Good. Here we go. We're flowing now. Okay. I think we've seen this one before. We're going to have a problem just like this on the test. My refrigerator has 48 cans in it. There are 28 Pepsi cans right here and 20 Coke cans right there. Find the probability, so it's got to be a decimal, that if I randomly take 15 cans all together, right, that's what I'm taking, 15 from my 48 cans, that exactly 7 are Pepsi. So the Pepsi was the green, right? 7 are Pepsi and 8 are Coke. Okay, so this is how you set this up. What you need to do, I kind of like, I do this table thing. Okay, all together we have 48 cans of pop. Okay, 48 cans. Okay, that 40 cans split in two ways. One way is the Pepsi, which is 28 cans, and the other way is the Coke, which is Coke, and that's 20 cans. Okay, from those 20 cans and those 28 cans of Pepsi, you are selecting a subset of 15 cans. In that subset, you are taking 7 Pepsi cans and 8 Coke cans. So 8 Coke cans and 7 Pepsi cans. And you want to figure out the probability of selecting exactly 8 Coke cans and 7 Pepsi cans. Well, to do this, what you first have to do is figure out how many different ways you can actually choose this. How many ways can you choose 8 Coke cans from 20 and 7 Pepsi cans from 28? Well, that's in your calculator. When you put that in your calculator, it is 20 choose 8 times 28, this is the Pepsi one, choose 7. I should make that bigger, C. And what you have to do is, that's how many ways you can choose specifically 8 of the Coke and 7 of the Pepsi. You have to divide that by how many ways you can choose 15 cans from the 48 cans. So if we take that and put it in our calculator, it will give us the probability of choosing exactly 8 Coke cans and 7 Pepsi cans from 20 Coke cans and 28 Pepsi cans, as long as each one was like the probability was the same. So let's just punch that sucker in. 20 math over, that's the 3, okay, 20 math 3, 8. And then we're multiplying that by 28, 7, and then we're dividing that whole thing by 48. Now remember, if we had two things that are denominator, we would definitely need to use parentheses in the denominator. But when you're multiplying a big string of things in the numerator, that's fine. You don't need to put parentheses around that. The calculator knows that those things are going to be in the numerator. That's just how it's programmed. We put that in, we got 13.64. Doesn't want to add a special weight to the nearest tenth. So 13.64, we would round that at, 13.6. If I put that in correctly. And it has a percent there, so I'm going to put it in there, 13.6%. Okay, fingers crossed. This is a tricky problem right there. Oh, God, nicely done. Nicely done. Okay. Question 5. How many different ways can 10 people be seated around a circular table? This is the circular permutation problem. Okay, we got a circle right here. We got 10 people sit around it. I think that's 10 right there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. And we want to know how many ways you can sit 10 people around it. Well, what you do in this one, you take the number of people, 10, you subtract 1 from it, 1, and you take the factorial of that. So really you get 9 factorial in this problem. And so this turns into be 9 factorial. Let's figure out what that is. 362880. 362880. 36. What am I doing wrong? Yeah, there we go. 362880. Okay. I put that in right? I hope so. Got it. Okay. Moving on to this one. There are 5 finalists in the Mississippi Stillwater Pageant. How many ways can the judges choose of the winner and the runner-up? Well, in this one, you got to ask, does the order matter? Does it matter? If you were a contestant, would it matter if you got winner or runner-up? And I would guess it would. You probably want to win and not be the runner-up. And therefore, because order matters, you don't do that little division thing that you would do if order didn't matter. So there are 5 finalists in the Mississippi Stillwater Pageant, and how many ways can the judges choose a winner and runner-up? Well, you can think of it as 2 buckets. And then the first bucket you have, because there's 5 finalists, 5 options, and the next one you have 4 options. Same thing, you can do this another way. This is 5NPR2. Both ways work, but I like my way a little bit better. It's kind of easier. So we got 20. Check that out. Nice, moving on. Okay. A test consists of 20 questions. The students are told to answer just 15 of them. And how many different ways can they choose the 15 questions? Well, when they choose those 15 questions, did it say they had to choose the first problem and then the second problem? Was there an order to how they choose them? No, there's no order to how they choose these questions. It's just they have to choose these questions. So there's 2 ways to do this. There's the bucket method. Now this bucket method doesn't work really well because you got to have 15 buckets. And that's going to take forever. So let's just go to our calculator. We know this is a 20 choose 15 problem. We'll put that in our calculator, and then life will be good. We'll be done with that one. 20 math, and then put 15 in. What do we get? 15,540. Let's check that out. 15,504. Was it 504 or 540? What was it? 504. Good. Okay. Check. There we go. Moving on to question number 8. A pizza parlor offers a selection of 3 different cheeses and 9 different toppings. Okay, they should have a couple more toppings, I feel. And how many ways can pizza be made with the following ingredients? 2 cheeses and 4 toppings. Well, this is kind of like that probability problem we did earlier where you were selecting the pop cans and things, but it's a little bit easier. And you don't have to find the probability, you just have to find the number of ways you can do this. We know that there's 3 different cheeses, and we're just choosing 2 from 3. So how many ways can you choose 2 from 3? Well, 3NCR2. That's how you put in your calculator, right? And we got to multiply that by how many ways you can choose 4 toppings from 9 different toppings. And so that would be 9NCR4. Put those in your calculator and you've got your answer. So 3NCR2 NCR4. Hopefully I did that right. Looks good to me. So 378. Excuse me. There's 378 different ways you can do this. Okay. Check that. Good. Question 9. Find the number of passwords possible if the following patterns are used. Show your work. Okay, so we have 2 digits followed by 1 letter followed by 2 digits. So let's think of these buckets. We got, these are my digit buckets, and then I got 1 letter, so I got a letter bucket, and then I got 2 more digits. Digit. Now, because it's a password, order matters, right? If the password to my garage door opener was 5292, you can't put 9252 in there. That doesn't work. You got to do 5292. And because of that, you don't divide on this one. You just have to find how many different options you have for each. Well, a digit is 1 through 9. Or 0 through 9. If you count 0 through 9, you actually get 10 options if you include that 0. So each of the digits have 10 options, and it doesn't say I can't reuse it, so I'm going to keep on putting 10 options. Letters, if you count the letters up in the alphabet, there's actually 26 of them, so I'm going to put 26 here for that letter. There's 26 options for that. And we're back to digits, so 10 and 10. All you have to do is multiply all these buckets, and you get your answer. If I do that 10, 10, 10, that's 10,000. So 10,000 times 26 is 260,000, right? 260,000. Yeah, so if I put this in right, 2 There we go. Okay, moving on to a spinner problem. Okay, each number section is exactly 1/8 of the circle. Find, I don't know why it's fine, but I'm guessing it's find the probability of each event in the 3 spins of the spinner. Probability of each event in the 3 spins of the spinner. Okay, so we want to find all 3 numbers are more than 1. It's the probability that all 3 numbers are more than 1. Well, let's take a look at this. What we're going to do is we're going to shade all the ones that are more than 1 when I shade this. So 2 is more than 1, 3 is more than 1, 4 and 5 is more than 1, 6 is more than 1, 7 is more than 1, and 8 is more than 1. So if I were to spin this spinner, probability of it being more than 1 would be 7 out of 8. That's the probability of this. But I'm spinning this thing 3 times, right? That's what it says. Event in 3 spins. I'm spinning 3 times. So what's the probability it is going to be in that shaded region all 3 times? Well, to figure that out, because each spin is independent, you just multiply the probability of each individual spin. And since each individual spin is 7 over 8, we just do 7 over 8 times 7 over 8 times 7 over 8 for each spin. Each of these represents a spin. Okay? And if you want to put this in your calculator, I would do it like this. 7/8 to the third power. But you can just multiply them whatever way you want to do it. So 7 over 8 to the third. If you don't use parentheses here, you're going to mess up. So make sure you use parentheses. And we get 0.66992185 to say anything. I'll put it as a percent or a fraction. So let's 14.1. So let's do 66.99. Let's do 67. That should turn out right. 67.0%. Fingers crossed. Please work. Please work. Otherwise, we'll put in the fraction. There we go. Good. Moving on. Okay. Each number section is exactly 1/8 of a circle. Find the probability of each event in 3 spins of spinner, fraction, percent. All 3 numbers are 3 or greater than 5. Okay. It'd be nice to have that picture again. Let's use that picture for this one too. Okay, so going up a little bit higher. All 3 numbers are 3 or greater than 5. Okay, so 3 would be this one, right? That's 3. Greater than 5 would be 6, 7, 8. Okay, and we're spinning this 3 times. Well, 1, 2, 3, 4. 4 sections are shaded, so 4 out of 8 sections are shaded. So with that in mind, 4 out of 8 is the same as 1/2, right? So we have 4 over 8, which is equal to 1/2. There's a 1/2 chance that that spinner lands in one of the 4 regions or one of the regions that we want it to land in. And since we're spinning it 3 times, and each spin is independent, the probability of them landing in the shaded region 3 out of all the times would be 1/2 times 1/2 times 1/2. And we just multiply those. Well, it's kind of easy to multiply this. We got 1 times 1 times 1, which is just 1. We have 2 times 2 times 2, which is, don't say 6, it's 8. It's 8. So we'll just put, since it says a fraction, I'm going to put a fraction of 1 over 8. And check that. There we go. Okay. Here we go. A family has 4 children. Find the probability that exactly one child is a boy. So we want to find the probability that exactly one child is a boy. Oh, well, this, I think, if I'm ready, correct, this we're using binomial distribution on this one. Yeah, binomial distribution. So let's think this through. A binomial distribution says probability of something happening, exactly something happening out of so many, exactly so many successes out of so many failures, is NCR times P to the R times 1 minus P to the N minus R. Right there. That's the equation for it. And what we just need to do is figure out what this P is. What is our P? What is our N? And what is our R? And once we figure those things out, we can plug it in our equation, or we can put it in the graphing calculator and have it solve it for us. So first we got to figure out the P. Well, what's the probability when what's the probability a boy is born? Well, it's not exactly 50%, but let's just assume it's 50%. Okay. Now, how many a family has? What would our N be? Well, N is the number of trials. Trials looks like they had 4 children, so there was 4 trials. And how many successes? Not saying a boy is a success. I'm just saying that was the success in this situation. How many successes do they want? Which is having exactly 1 boy. They want 1 success. So here's how you put that into your calculator, unless you wanted to do it by hand. And there's nothing wrong with doing it by hand, but sometimes it's easier just to put it in your calculator. Once you do that. So we're going to do the combination. So we have 5 choose 1. Oh no, I'll show you. We'll go to, I'll circle it for you. We got to go to this distribution button right there. And in that distribution button is the thing we need. So we'll click second and then vars. And then if you push up, it's going to bring you to this thing called binom PDF. That's what you want for this situation because it's exactly binom PDF. And first thing you put in there is the number of trials, your N. So you put 4 in there. And then you push a comma. And then you put a probability of a success, which is 0.5. Put comma again. And how many do you want? How many successes do you want exactly? You want 1 success exactly. Close that off. Push enter. And the probability of this happening is 25%. So how do they want it in there? On your answer, the nearest decimal. Oh, it looks like it's just going to be exactly 0.25. I don't think I can. Yeah, there we go, 0.25. Check that. Oh, good. So, oh, here we got another one. Coin is flipped 8 times. Find the probability of flipping exactly 6 heads and 2 tails. Well, let's just say 6 heads is our successes, 2 tails. You could go either way. That's the neat thing about this. So, really what we have is binomial distribution. So, binom PDF. How many times are we flipping it? 8. So, we're flipping it 8 times. So, our n is equal to 8. Our p, what's the probability of getting ahead of success? Well, that's 0.5 again. And what's the probability, or how many successes do we want? We wanted 6 of them, so our R is equal to 6. Now, I bet if you tried putting 2 in there, you get the same thing. You can give it a shot. I bet you get the same thing. So, 0.5 and then 6. So, let's give that one a shot. So, I'm just using the last one. I'm going to change it around. So, we have 8.5, 6. Push enter, and you get to the nearest 1,000. So we need to go a lot down there. Oh shoot, look at it again. 0.1093, but we round up. So 0.1094. No, that's too far. 0.109. Yeah, there we go. 0.109. Check it. There we go. Okay, moving on. Question 14. 2 number cubes are rolled, okay? The numbers on the top face are recorded. Find the probability of the following events. Sum less than 7, sum greater than 8. So let's go to my number cubes. So we're looking for a sum less than 7 and a sum greater than 8. Go to the second page. I've got number cubes on the back here. We'll just clear this ink out. Okay. So we got this thing represents number cubes right here. A number cube has 6 sides and 6 sides, and when you roll 2 cubes, you can just add them together and see what you get. So the first thing was a sum less than 7, so we're going to shade everything below 7. 2. Right, okay. And I think, what else do they want? Sum was less than 7 and greater than 8. So we'll go back to it, greater than 8. So we're pretty much just not shading the 7s and the 8s, it looks like. Now what you need to do, the probability of this happening is because there's 36 squares on each of these, there's 36 squares, you just figure out how many you shaded in and just do that in your numerator. So 36 in your denominator. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25. I hope I didn't count too fast. So I got 25 over 36. I'm pretty sure you can't reduce that down. Last I checked. So let's just put that in. 25 over 36. Okay. What does it say? Right, your answer is a simplified fraction. 25 over 6. Check it. There we go. This is going well, other than that first problem. Okay, a card is drawn from a standard 52 card deck. Find the probability of the following event: a red card or a 6. Red card. Oh, okay. Write your answer as a fraction in simplified form. Okay, let's go back. Go back to it. So we wanted a red card or a 6. That shouldn't be too bad. So work our way up to our cards. So for this, we'll just shade in all the red cards and we'll shade in all the 6s. So here are all the red cards. How many red cards are there? Oh, that's 13. And then we got to shade in all the 6s. We'll do that in a different color just because I can. Okay, now in the problem, it was an OR. An OR, when it just says OR right there, you know you just have to count up all of the cards that are shaded. Do not double count. All the cards are shaded just once, and then put that over 52. And the reason it's 52 is because there are 52 cards in a deck. What happened? Shoot. I thought I shaded these. Didn't I shade these? Am I going crazy? Okay, all the red cards, and then all the 6s. Okay, so 13 plus 13, and then we gotta count these guys. So this was 13 here, this is 13 here, that's 26, 27, 28. So really we have 28 out of 52. That is 14 over 26, and that is 7 over 13. 7 over 13. Isn't this like the problem I got wrong? I didn't count. Okay, 17 over 13. No. 7 over 13. No. Checking it. Fingers crossed. Good. Okay. Moving on to question number 16. Using a standard deck of cards, if event A is drawing a club and event B is drawing a face card, find probability B given A. Okay, so this is we're going to go back to the cards. Now, A is a card is a club and B is card is face card. Now, we want to find probability of B, which is a face card. That's right here. Given it is a club. Okay, that's that. Now the given is always in your fraction the denominator. Okay, so how many clubs do we have? Well, if you count, go to our cards really quick, and I don't know why it's still there now. Let's clear it this time. If you count them all up, this is the row of clubs right up here. And if you count them, we start with 1, go to king. There's 13 clubs. Okay, so this is the focus right here. There's 13 clubs. So that will be our denominator, 13. And now we got to figure out, of those 13 clubs, we don't care about anything else, okay? You understand that? This stuff doesn't matter anymore. We just care about the given, the 13 clubs. How many are face cards, right? That's what they want to know. Well, we have 1 face card here. Let's do this in a different color so you can see what I'm writing. 1 face card there, 2, and then 3. So 3 face cards all together. So if we work our way back, this should be 3 over 13. And thankfully, we don't have to reduce that. Okay, I'll check it. See how I did it. Moving on. Great. Okay. Oh, good. Here's some cards already included in there, so hopefully this helps you out. Using a standard deck of 52 cards, find the probability an ace is drawn given a black card is drawn. Okay, so this is another given one. Maybe this won't work on this. I'm going to still use my file of cards. And remember, make sure you ask me for these cards and this dice, the sheet that I have all the cards on there, so you can keep on shading and scribbling all over stuff. Okay, so using a standard deck of 52 cards, find the probability an ace is drawn given a black card is drawn. What? What is this? Why does this say face card and then red card? You write your answers. It's like almost 2 different problems in one. Why does this one say face card and then red card, and this says ace is drawn given a black card is drawn? Which one should I try to solve? Let's try to solve both of them. We'll do the first one first and see what we get. An ace given a black card is drawn. Okay, so the given is the black card is drawn. So we have this many black cards, right? This is the black cards. Of those black cards, there's 26. There are 2 aces, so you have 2 over 26, which is just 1 over 13. So let's see if that's the right answer on that one. 1 over 13, is that what it's asking for? 1 over 13. Okay, see if I got this right. Nope. Okay, so it's not asking for that. I got to change this problem. What about a face card given it's a red card? Well, let's go back to it. Given us a red card, there's 26 red cards, so that doesn't change. How many are face cards? 6, which reduces down to 3 over 13. So let's see if that's the answer. Going back to that one. Hopefully one of these is the right answer. So a face card given us a red card. Okay, checking it. There we go. Okay, so I gotta fix that. I'll fix that. Use a standard 52 cards, find the bottom thing. Okay. Noted. Oh, last problem. Okay. A person randomly selects answers to all 10 questions on a multiple choice quiz. I don't know why they would do that, but they did it. Each question has 1 correct answer and 3 incorrect answers. So altogether there are 4 possible alts. So you got A, B, C, and D. That's what that's saying. Find the probability that at least 8 answers are correct. Oh, at least. Okay. 8 answers are correct. So this is a little bit more difficult, because now we're not talking about exactly 8 answers are correct. If it was exactly, you could just do binomial, the binom PDF, and then you could put the, you could put the 8 in there. Right? How many? Oh, sorry, 10 in there, and then the probability of it being correct. What is the probability of being correct? Oh, 0.25, and then you choose an 8. Okay, but that's not what we're doing. We're doing we're doing this multiple times. We need at least 8, so we need not only the 8 here that we have, but we need it to be added to bin PDF of 10, comma 0.25 and 9, because 9 is also okay. You can still get 9. That's alright too. And we also need bin PDF of 10, comma 0.25, comma 10, because it's okay for you to get all 10 right as well. So it's like we have to put this in 3 times. Let's see. Gosh, I wonder if there's an easier way to do this. Let's just, I don't know. Let's just try this. So we got bin gnome PDF, and they're pretty similar. So we start with the 10, comma 0.25, comma, and then we need 8, and then we're adding it to another bin. So we'll put another one in. Bin gnome PDF, and it's still 10, comma 0.25, comma 9, and then we're going to add it to another one. (10, comma 0.25, comma 10). That looks good. I think that's good. So we'll push enter on that. What? What did I do wrong? What did I do wrong? Did I put something weird? 8, bin PDF, bin 10, comma 0.25, 9, 10, comma 0.25, 10. So the probability, 1 correct answer and 3 incorrect answers. Probably getting at least 8 correct answers. 8 answers are correct. So it's really small. That's a really small answer. I don't see anything wrong up there. Did I add something weird? Bin gnome PDF, bin gnome PDF, bin gnome PDF. So if I'm seeing it, it's 0.1234. Check it. Well, I guess that's right. Okay. Woo! It's a tough problem right there. But it looked weird. But okay, so going back, just so you can see this. This right here, I got the 4.1580 because it says E. See this E -4. You got to keep your eyes open for that. But that means you got to take this decimal point and move it to the left 4 spots, 2, 3, 4. So I did that. 1, 2, 3, 4. Put that decimal there, and that gave me it as the decimal that I needed. And I could put that in there. So everything looks good on this. That's how you do all these problems right here. I hope this helps out a little bit, and this helps prepare you for the actual test. Take care.